Hi everyone, welcome to Enterprise Manager Technology Forum 2023. My name is Prashant Dikshit, and today I'll be talking about on how to minimize risk and maximize confidence in your move to Oracle Multitenant. All right, so these are a few of the things, the overall agenda that I'll be talking about today. So before I move ahead and start talking about the real technical stuff and the discussed agenda, would like to give a quick background about my company, the organization, the place where I work. I work with this company, CBTS ONX, as a database architect in their Toronto, Canada office. As an organization, we are a leading IT service provider in the region North America. We are a strong group of consultants having great experience in your databases and application administration, migrations, system stabilization, full stack upgrades, performance tuning, and digital transformations. Now, that's that's me wearing a Viking hat. I am an Oracle associate and I have more than 17 years of experience into information technology, especially into Oracle databases and related technologies. And I'm the man behind the Oracle blog that's called fatdba.com, and that's the place where I share all of my learnings, experiments, and issues related with Oracle database performance tuning, system optimization, and advanced level of troubleshooting sometimes. So that's a quick note about my team. We call ourselves database engineering team, and that's a solid group of database administrators, developers working for our customers from different domains and industries for their database application, middleware, and operating system needs. All right, so this is a very common slide, and most of us are already familiar about it. This architecture of Oracle Multitenancy, this concept of CDB PDB. So yeah, this slide is about Oracle Multitenancy, which was introduced in Oracle 12c Release 1, 12.1. And I am not going to explain about the multi-tenant architecture, as most of us already know about it. If not, here are some quick notes on what makes it different than the non-containerized Oracle database installation. But the question is that you want to try multi-tenancy, but afraid to upgrade. I mean, I've seen a lot of customers, architects, their DBAs, they don't want to adopt or move to Oracle multi-tenancy and still sticking with their non-CDB architecture. I mean, a lot of times during the customer calls and handshakes, few of the top reasons they give are performance of their critical workload, stability of their database, and compatibility issues as some of the reason they don't want to move to Oracle multi-tenancy and still using non-containerized or non-multi-tenant architecture of Oracle. So with that question that we discussed in the last slide, so this is again a very good question, to ask or a demand from the customers, like they want to decimate, they want to eliminate the dangers when it comes to migrating and implementing changes. So, I mean, all during those numerous customer calls that I had so far, like I have jotted down some of the top questions that they always ask from me and my team. Like we have some daily DBA task. What will be the impact on the database performance on the newly upgraded database? What will happen to those fixed routines which were running on this existing system from a very long time? How they will perform, how they'll behave once they migrate to this new architecture, which is now containerized or which is now moved to a different version of Oracle, right? So another question that I remember, like what they usually ask is how to identify and deal with the regressed SQLs, like SQL with a huge runtime divergence. For example, they're always afraid of they have this critical SQL which is part of a critical workload, a critical application, a batch run that happens every day, few times a day, right? And it usually takes 15 minutes to complete that run, right? So they're afraid of moving that SQL, that particular workload to this new system because they don't want to, listen that job is now started taking 20 minutes or 30 minutes or whatever that's the benchmark, so it start taking more than that. So they're always afraid with that huge runtime divergence, like what will happen to the SQL workload. And the third question I always hear from the customers is how to load and throughput testing of the workload, like how exactly they'll do the end-to-end testing of this workload, how to simulate my peak workload on the new system, right, which is soon going to be a new system. So what exactly will be the process, the tools that we should use to simulate my production load there on this new system? And the another question is how to identify the best, most favorable or desirable approach to migrate our databases. So yeah, these are, I can mention a few more, but these are some of the top questions that we always receive from our customers. So though Oracle Multitenancy is not making our lovely Oracle database any different. It's just a change in the architecture. And as far as performance and constancy or stability is concerned, you don't have to worry about it. Oracle Real Application Testing and few of its components, example, Database Migration Workbench along with SQL Performance Analyzer and Database Replay will help you to smoothly enter into this world of multitenancy. I remember a few times customer asked me the question like, what are the issues with the typical testing tools? Can we use tools like Apache JMeter, Postman, HammerDB, or maybe SOAP UI? Can we use them? And my answer is most of the tools that I just mentioned, right, are used to simulate application API calls, which is not always the right simulation of application calls to database. So especially in the case when your application is complex or the test workload is not accurate or complete or not a complete representation or a true production workload. So yeah, so you basically need a tool that can help you to capture the exact peak workload from your current production database and mimic or play back them on the same order in your soon-to-be production system. And the answer for that question is Oracle Real Application Testing, or RAT. Okay, so this is a kind of a high-level architecture diagram for real application testing. On your right, in the blue color, you are seeing a production database system, your existing production system, right? And on the right, in pink color, you are looking into a soon-to-be production database system. So once you have identified the time duration you want to capture and replay on the new system, you can either use the command line way or you can use Enterprise Manager to call dbms_workload capture.start capture. So that's basically will be the very first step once you have zeroed down or once you have that duration that you would like to capture and replay on this capture from your existing production system source and want to replay it on your target system. So once you have that thing ready, then the first step that you have to do is to run this package dbms_workload capture and its procedure start_capture to start capturing the SQLs, the workload on the source system, your existing production database. So let's assume you would like to capture only 60 minutes of your peak workload during the business hour. Once that is completed, you have to use another procedure, finish_capture. And that will initiate the workload capture on all of your instances. All right, so that's about step number one. And at the step two, you will now move all your captured files or the recording files with .rec or rec extension to your target system. Now, before moving to step number three, and you start replaying the traffic you have captured from the source, we have to make sure the source database is restored on the target. And it should be restored to match the source database at the start of the capture. This is required to avoid any failures with the replay process, right? Now, once the restoration of your database is finished, as a step three, on the target, you will fire the recommended number of WRC or workload clients on the target database to replay the captured workload. And to get an exact number of the workload clients that you need to run your load, you have to run WRC utility in the calibrate mode. And once you have the required number of workload clients running, you can next start the replay process on the target using DBMS underscore workload underscore replay package and its procedure called as start underscore replay. And you are done. You now have to wait for the replay to finish. And once that is completed, next you will generate the regular AWR reports, hash reports, and some RAT specialized reports, which will give you more details about the run on the target. So these are there are few intermediate steps as well, like processing the capture, initialize the replay, preparation or prepare of the replay, which I'm not explaining here. And they're very well documented, defined in real application testing or RAT official documentation. I'll provide you the link at the end of the presentation in case if you want to know more about it, about those steps. All right. So yeah, let's move to the next slide. This is again about the database replay that happens on the target system. You're soon going to be production-like environment. So though we have already discussed about the replay in the last slide, but I would like to talk a few more minutes about this replay concept. So this is how it looks like. What you're seeing on this on the slide on the presentation. This is how it looks like if you're replaying through Enterprise Manager, which gives you a single pane view with the help of a few clicks that you can do to entirely automate or do the capture and replay thing for you. Here in the screenshot, I have created a test replay. I mean, I'm talking about the screenshot that's there on the left, right here, and I have created a test replay task for the target. As a subpart, there are a few things that you can see under the task list. Where we are preparing the test database that can help you to clone your production database and restore it to your test host or on the target. And within the same screenshot, you can see that you can even pre-process your workload and deploy the required number of replay clients. And the final task will replay the pre-processed workload on your test copy of the production database. And on the right side, it's basically a summary screen that you will get once you initiate the replay, which will provide you all runtime statistics related with your ongoing replay. Few of the important things are like average number of active sessions or AAS, details between the capture and the ongoing replay, number of the user calls replayed so far, total duration of the replay, and more details on the differences or the deviation of your SQL statements and the total workload. Next slide is about a very important and cool tool, a utility called the SQL Performance Analyzer or the SPA. So the SQL Performance Analyzer or the SPA is a part of Oracle Real Application Testing Pack, and you can use it to validate changes made to the database system. So SPA provides a fine-grained assessment of your environment changes on the SQL execution plans and stats by running SQL statements in isolation and serially in before change and after change environments. So the image on the top left is a kind of a flow diagram to understand it better. So it first captures the SQL tuning sets, runs pre-change trails, and make the change for the SQL statements. And from that point, you have two options to choose: either implement tuning recommendation, or you run post-change trials and then compare the SQL performance, study the comparison reports, and that will prepare and then implement the best possible solution of the tuning recommendation. And to make it a little more easy to understand the SPA thing, I have few snippets that you will be able to see just before this flow diagram are few of the snippets from the capture versus replay report from one of the system, where we can clearly see two of the regressed select statements marked in red, and first one took 5.9 hours and 0.6 hours respectively to complete. So which is, for the first one, it's 7175% of the change in the average response time, and almost 6861% for the second one. And this is the best use case to try and test and tune them using SPA before you implement the solution in the target system. And the good thing about the SPA functionality is it's very well integrated, couples with existing SQL tuning sets, SQL tuning advisor, and SQL plan management functionalities. I guess it will be good to explain it through a quick demonstration, a quick demo, a short video that I have prepared just to show you how this SPA thing works in conjunction with the SQL Tuning Advisor and how it can save all of those performance nightmares and can help us to avoid SQL performance degradations, which might happen on the target database after the movement. All right, so this is the Performance Hub page, and here if you see, like, this is one of the SQL that's very heavy or costly in terms of CPU usage. So once you click on that SQL and click on Tune SQL, then you go and create or schedule a SQL Tuning Advisor. And once you click on the Submit, then it's where you started doing the work. It's create a new SQL tuning set for you. Just give me a second. All right. And once that part is finished, then it's basically giving you two recommendations. First is either you can go and create a SQL profile, or else you can create an index. These are the two automatic recommendations given by the SPA. And now after that, you have two options. If you want to implement this finding, this recommendation, or you want to validate it with the SPA, the second tab if you see here, right? So before going and implementing any of these two solutions, like for example, we are not sure if the SQL profile will give us any benefit. So for that, it's it's a little risky to implement, right? So we'll go and validate with the SPA. So I'm going to click on that option, and that will take you to another page. And so if you see, like, success to submit your validation SQL profile using SPA, so that has been successfully submitted. And next, it will basically do some comparison. And once that comparison is completed, here you'll see it has performed several trials of this SQL statement in the current existing environment. Sorry. Oh, what has happened? Okay, let me directly take you to that page. Yeah. All right, so once the trials are successfully completed, and the next thing, it will provide you the result. Here, if you see, this is the final result, and it says that's not a good idea, because if you check this regression impact, it says minus 873%. So it's not a good idea to go and implement or create the SQL profile. That's what basically will worsen the situation and will not improve the SQL performance, right? So it's good. Like, it also giving us few recommendations, like if you want, you can go and create a SQL plan baseline, or if you want, you can rerun the SQL Tuning Advisor, or if you want, you can create the SQL tuning set again. So here at this point, so it's clear, like, out of the two recommendations that SQL Tuning Advisor gave in the beginning, first is to create a SQL profile is not a good idea. So maybe we would like to try with index creation, if that will help us to solve this performance issue with the SQL. So yeah, that's how the SQL plan performance analyzer, or the SPA, works. All right, so let's quickly move to the next slide. That's about the performance reports, the RAT-specific performance reports. So along with the regular performance reports that we all are familiar with, like AWR, Active Session History reports, or ASH, ADDM, Real Application Testing has its own special reports. These extensive reports are provided to enable detailed analysis of the capture and replay. Any errors encountered during replay are reported. I mean, any divergence in rows returned by the DML or queries is clearly shown. So basic performance comparison between capture and replay are provided through these reports. If you want to do some advanced analysis, replay compare, period reports are available that allows detailed comparison of various statistics between capture and the replay. So here in the slide, we can clearly see capture report snippet, the replay report, and the capture versus replay report. So these are very useful for the cases when you have to do the performance analysis between source and the target database after the replay is successfully completed or is finished. All right, so next one is about what new was added in Oracle 19C. So this slide is about a very cool feature that was added for real application testing in 19C. In pre-19C versions, you don't have the option to capture and replay your SQL workload from and to a PDB, and was only limited to the CDB or the container database. But starting from 19C, now you have the option to do it at the PDB level too. The bottom of the slide, I've also added a link to Oracle blog from the same subject, which I've authored along with real application testing team, and will give you more details about the steps to implement it at the PDB level. I request you to please go through it if you want to read more about it. All right, so these are, in this slide, I have tried to provide you some high-level steps on how to do the capture and replay at the PDB level. Again, for more details, I request you to please go through the link, which is provided at the bottom of the slide. But these are the steps that you have to do on the source system, followed by the steps that you have to perform in the target. So as a step, like very first thing that you have to do in the source is to create a capture directory on the source database and then start capturing your PDB workload. And once that part is completed, then you have to transfer your workload files on your, soon going to be production database server. So these are a few of the things that you have to do on the source. And once that is completed, then you have to move to your target PDB on your soon going to be production database. That's where you create the replay directory structure, process the captured files, and initialize the replay through the workload clients. And then after that, you remap the connection strings, because your workload has connection strings from your production system, and you want to point them to the database so that the user sessions will be able to easily connect in the desired way or in your desired way during the workload replay. And after that, you go and prepare your workload replay and then start replay the process on the target that will start throwing that production capture workload on your target. And finally, if you want, you can create or you generate any of the performance comparison report between your capture and the replay. Okay, so this is again a very important slide, and this is where I've tried to highlight a few of the top practices that you should follow in case when capturing or replaying your workload using RAT. So the first one is, like, I've seen sometimes people don't have clarity. They always gets confused about the peak workload time. I mean, what time of the business hour we should capture and replay? To answer that one, there are two good ways to do that. Either use EM, Enterprise Manager, IO-related metrics section, which will give you some good-looking historical graphs, or you can also use ASH views or active session history views, especially db_hist_systat, and its dynamic view equivalent or counterpart called as systat, to get some IOPS specific information, which you can later on plot in some kind of a graph to get the time where you have maximum number of read and writes happening in the day. So that will be the time you would like to capture from your production. As a second best practice about the workload clients, which are used to replicate or simulate real-time workload replay on the target system. If you want, if you want, you can start them on the same target machine, but it's highly recommended to run them on a separate host because they consume a lot of resources. They need CPU, they need memory, and they do a lot of IO that can impact your replay's performance. As a third best practice, like processing captured files on the target, this is a one-time task, a one-time activity where the workload is processed by real application testing. Once you did it for the first time, then you don't have to redo it. You can simply replay as many times as you want on the target. Next is, as pre-processing is a long activity, if you want, you can do it on a separate seed database while you are using the database for other tasks, maybe for creating capture subsets and writing the filters, etc. Continuing the same slide. Next point number 5 is, as you have to replay the workload a few times before you are satisfied with everything and you have fixed all of those regress SQL on the target, it's good to create a GRP or guaranteed restore point just before you go and do the replay, which makes your data files dirty, right? So this way you can save a lot of time, which you otherwise be spending doing RMN restores or imports. Next, point number 6 is the synchronization parameter, which basically controls the synchronization methods used for the database replay. So it's always good to try different synchronization models or modes that are available and decide which one best suits your workload. There are a few of them, like time that will basically replay will happen use the same wall clock timings as the capture. The other type is to set it to SCN, where the commit order is captured workload will be observed during the replay, and all replay actions will be executed only after all dependent commits actions are completed. And the third one is object_ID, where all replay action will be executed only after all relevant commits action have completed. Okay, the next best practice is in case if you're using real application databases, real application cluster databases, rack databases, you can map all your connection strings to a load balancing connection. This is quite useful if number of rack nodes on the replay system is different from the capture system. And you can you also have option if you want to point at the workload to specific instances. You can use services or separately assign the instance identifiers in the remap connection strings. Next is one is about resuming and pausing your replay. I mean, many of the times I've seen people, they simply stop the replay in case they want to perform anything in between the workload replay. So the DBMS_workload_replay has two good procedures now, which you can use to temporarily pause it and resume the workload on the target later on. I mean, there are many other good practices about running your real application testing, capture, and replay, but these are some of them which I use quite frequently. For more, I request you to please check Oracle's official documentation on real application testing and few of the good Oracle support document IDs that's there on the Metalink side. All right, so that's the end of my presentation. Here we have few good links to read and watch more about Enterprise Manager, real application testing, and other observability subjects. And please don't forget to try Oracle Cloud free tier. There is a 3-day free trial that you can use to test more services. Okay, so I appreciate you all coming and attending the session. Thank you so much.